All right, finishing up our lesson on max and mins 3.1. We really only have this last page to go. We're going to alter the page just a little bit. It says use a graphing calculator to estimate the absolute max and min values. We're not going to do that. We are not using the graphing calculator, so please don't do that. We're simply going to do part B. Use calculus to find the exact min and max values. So the idea is, if we want to find the absolute max and absolute min values of a function, we take its derivative. So we're going to need f prime of x. In this case, f prime of x is going to be the derivative of x, which is 1. The derivative of 2 sine of x is 2 cosine of x. And critical values are found where the where the derivative is equal to 0 or where the derivative is undefined. 1 minus 2 cosine of x is never undefined. It's two functions which are continuous everywhere. So all we can do is set this equal to 0 and find where this thing is going to have a slope of 0. So if you subtract 1 and then divide by negative 2 on both sides, you would get that cosine x equals a half. So really we're looking for the angles, and it does have a restricted domain from 0 to 2 pi. Between 0 and 2 pi, where x, or where cosine is going to be 1/2. And of course that occurs at x equals pi thirds and x equals 5 pi thirds. Both of those two angles will give you 1/2 when you take cosine. So according to our extreme value theorem process, we need to figure out the y values at the critical values. So pi thirds and 5 pi thirds. And don't forget that absolute max and absolute min values can not only occur at critical values, they can also occur at the endpoints. So we need to also check 0 and 2 pi. And remember, we're taking those x values and we're plugging them back in to the original function. And that's because the original function is going to give us the y values. If we plug these back into the derivative, we're just going to get slopes. That's not what we're looking for. We're looking for the actual maximum values. So let's do the easy ones first. If I plug 0 in, plugging 0 into f of x, we're going to get 0 minus 2 sine of 0. Sine of 0 is 0, so I should get 0 minus 0, or 0. That should be the easiest one on there. 2 pi, be careful, don't make the same mistake, because yes, sine of 2 pi is 0, but you got to plug 2 pi into x as well. So it's 2 pi minus 2 sine of 2 pi, or 2 pi minus 0. So it's 2 pi. All right. It is the pi thirds and the 5 pi thirds that are going to give us a little bit of an issue, especially if you have to do this without a calculator. So we're going to need to figure out what f of pi thirds is and f of 5 pi thirds. I'm going to leave a little bit of room there. F of pi thirds, plugging in pi thirds into my function, is going to give us pi thirds minus 2 sine of pi thirds. So we need to know sine of pi thirds, which is square root of 3 over 2. So we get pi thirds minus, now if it's 2 times square root of 3 over 2, 2's will cancel out and you just get square root of 3. So pi thirds minus the square root of 3 is the f of x value when x is pi thirds. Let's figure out what f of 5 pi thirds is. Well, it's going to be plugging in 5 pi thirds for x minus 2 sine 5 pi thirds. So that's going to be 5 pi thirds. Sine of 5 pi thirds is the same thing as sine of pi thirds, which is square root of 3 over 2, but it's in the fourth quadrant, so it's going to be negative. So that negative times the negative out in front of the 2 is actually going to make this a positive square root of 3 when you reduce it. So we've got 5 pi thirds plus the square root of 3. So now here's the thing. If you don't have the access to a calculator, you're going to have some pretty decent estimation techniques to be able to tell what's going on. First of all, there is only one possible value up here which could be negative, because 2 pi is not negative. 5 pi thirds plus some value pi thirds is not going to be negative. 0, of course, is not negative. The only one that could be negative is pi thirds minus the square root of 3. It's the only possible thing that we could have to be an absolute min. Otherwise, it's going to be 0. So we have to come up with an estimation technique. Well, here's what you need to think. Pi is approximately 3.14. So if I do pi thirds, that's going to be 3.14 divided by 3. Well, it's a number a little bigger than 3 divided by 3. It should be a number which is just a little bit bigger than 1. Okay, hopefully you guys are following that. So if I take a number which is just a little bit bigger than 1 and I subtract the square root of 3, the square root of 3 is something that you actually should know an approximation of. The square root of 3 is approximately 1.7. So if I take a number just a little bigger than 1, subtracting 1.7 or so, we're going to get a negative value. I don't care what it is because it's not really what it's asking. I don't have to give the decimal approximation of this. I just need to know it's negative. And because it's negative, it's the only negative value of all my f of x critical values. So this has to be your absolute minimum. There is no other possibility. It's the only negative value on there. All right. Well, 0 is definitely not a max. The pi thirds minus square root of 3 is not a max because it's the absolute min. The only two possible values that could be the maxes are 2 pi or 5 pi thirds plus square root of 3. Again, estimation techniques are going to come in handy here. We know that 2 pi is about, let's see, 3.14 times 2 is about 6.28, and that's an approximation. And again, this is just for our own knowledge because this is approximating. 5 pi thirds, same exact idea that we did before. So if we did 5 times, now remember pi thirds was approximately a little more than 1. So if I multiply that by 5, it should be a little bit more than 5. So if I take a number which is a little bit more than 5 and I add approximately 1.7, at the very least we're going to get 6.7 something. It's probably a little bigger than that actually. But either way, you should be able to tell this is bigger than that. So this one is our absolute maximum. And the only reason I'm not writing this out again is because I'm kind of running out of room. Otherwise, you really don't want to do what I just did and box the answers and put arrows and stuff. They don't like that. So don't do that for real. But your absolute minimum would be pi thirds minus square root of 3. Absolute max, 5 pi thirds plus square root of 3. And that's using good estimation techniques. All right, last example. This is probably my favorite one. I wish we could have done this one in class because I actually like talking about what's actually happening here. This is actual data. This is real life stuff right here. So it says the Hubble Space Telescope was deployed on April 24th, 1990 by the Space Shuttle Discovery. That is actually true. That's when it happened. A model for the velocity of the shuttle during the mission from liftoff at t equals 0 seconds until the solid rocket boosters were jettisoned at t equals 126 seconds is given by that messy looking velocity function right there. And that is actually the velocity function that they came up with based upon the actual velocity of the shuttle during its liftoff from those two times. And hopefully you guys have at least seen enough TV or whatever to know when the rocket boosters were jettisoned, it's those big boosters on the side that come flying off once that shuttle gets high enough. Excuse me. So what we're trying to find, we're going to use the model to estimate the absolute maximum and absolute minimum values of the velocity of the shuttle from liftoff to when they jettison the boosters. If we need the absolute max and absolute minimum value of the velocity, that means we need to take the derivative of the velocity because we need to find its critical values. This is not something that you would do without a calculator. This is a calculator problem. You can tell by the awful decimals out in front. So the velocity derivative, which we also know should really be the acceleration, and we'll tie all that stuff in at some other point in time. The derivative of the velocity is 0.003906 t squared. That's bringing the cube out, multiplying it, and reducing the power by 1, minus 0.1805 0.58t plus 23.61. Okay, that's the derivative of velocity. If we want to find its critical values, once again, that's a polynomial, so it's not undefined anywhere. We would set it equal to 0 to find the critical values. This is something you would plug into your calculator, and again, I wish this was something we could have done in class because I would have had you guys practice this, so you should probably try and practice this at home to make sure you can see it. One, your x values must go from 0 to 126 on your calculator in order to be able to see the entire graph. And then two, you should recognize that 23.61 is the y-intercept, so you're going to have to make your y maximum relatively high. I think if you go as high as like 60 or 70, I think you can see the whole thing. 100 definitely for sure. You'll see the entire velocity graph between 0 and 126. Now, because I don't have the aid of the calculator here, I'm going to show you what it kind of looks like. If you're looking at your window of your calculator, I believe that if you go from, like, this is 0 to 100 and that's 0 to 126, it looks something like this, if I'm not mistaken. Maybe it's lower, maybe it's higher, but that's the general graph. We're looking for when the velocity, which is that blue line, is 0. Well, according to this, the velocity never hits 0. Or, excuse me, the derivative of the velocity never hits 0. Which means it has no critical values. Well, if we're trying to find the absolute max and absolute min, but we don't have any critical values, there's only two possible places now it could be. Because absolute max and absolute mins occur either at the critical values or at the endpoints. Well, since there's no critical values, the only things that could be the absolute max and absolute min are the endpoints. So we need to evaluate the velocity at the endpoints. And the endpoints here were time equals 0 and time equals 126. Okay, so if you go back to your original velocity function, you plug in 0, that's actually easy because all the t's go away, and that leaves you with negative 3.083, and this is feet per second. And then if you plug in 126, that one you actually would have to plug into a calculator to figure out, you should get 4,142.822 or 823 if you round the last number, feet per second. And that's pretty easy to tell which is the max and which is the min. The bigger one is the max, the smaller one is the min. So this one is your absolute max velocity. This one is your absolute min velocity. And again, what I'm doing here is not good. You don't just put arrows to it and say that that's absolute max, absolute min. You would rewrite it back down on the bottom of the page. But what I find interesting about this, and again, I am completely fascinated with space and space travel and all that kind of stuff, is if you've ever actually watched the video of a actual space shuttle launch, your initial velocity here is negative, which means that when the shuttle is first released from the clamps, the negative direction would be down. That means that this thing actually goes down. The shuttle actually goes towards the ground before it goes up. And if you've ever actually watched it, the shuttle drops for that split second, and then it starts to go up. And that's exactly what's happening there. So the shuttle's velocity for only a micro, like a second or something like that, not even a whole second, drops before it starts to go up as soon as those clamps are released. And then the other thing I find really interesting is, if you know things about conversions, I don't remember the exact amount, but a mile is approximately like 5,200 feet or something like that, or 5,100 something feet. This thing is moving at almost 1 mile per second by the time it gets to be 2 minutes away from Earth. That is really, really fast. And that's why you feel all the G-forces and stuff pulling on you, because you're working against gravity going up, plus you're moving at about 1 mile per second. That's crazy fast. Anyway, that's my own fascination. Anyway, kept the video to a little bit less than 15 minutes. You guys now have the rest of the material, and hopefully that's all you need to be able to finish the assignment.